So just be patient with me. Okay. All right. End behavior. Okay. You guys, if we graph the line y equals x, it looks like this. So just grab your pencil, draw a line, something about like that. Okay. Y equals x to the third looks something about like this. It's a cubic. It was one of our parent graphs that we just learned on 3.5. Someone talked to me about y equals x to the fifth. What does that look like? Compare it to x to the third. How do they compare to each other? The same ending, the same idea. How's x to the fifth different? Gets steeper, faster. Like if it's a 2, instead of being an 8, 2 to the fifth is 32. So it would be really steep, right? So it's the same idea, just gets steeper, faster. Okay? Okay, so everybody look at these things, what they have in common, okay? So this exponent is a 1. And this is a 3, and this is a 5, so they are all odd, okay? Now, I want you to look at the left-hand side. Guys, look what's happening. This left goes down, this left goes down, and this left goes down, okay? Now, I'm kind of picky about the arrows that you're going to draw, okay? So look at the left side of a box. Your left arrow is either going to point to the left upper corner of a box or the left lower corner of a box. So look at these three graphs. They're all left down. So your left arrow is going to be left down. But I have to point to that corner of the box. I don't like this. I don't like straight down because that implies that those go straight down. And they don't go straight down. There's always an outward motion to it. Who says I understand what you're saying? Raise your hand. Okay, great. Look at the right side of all these odd graphs, okay? So that this goes right up, and right up. So everybody look at this box. You've got a right upper corner and a right lower corner, and they all went up. So now I'm just going to take my pencil here, and I'm going to point to the right upper corner, and that is called an end behavior. Here's what end behavior means, guys. Look, as x gets really, really big, and as x gets really, really small, where's my graph going? So on this one, it goes like that. Okay? Okay, look at the next one. X to the second, x to the fourth, and x to the sixth. So grab your pencil and just very casually sketch in an x to the second. Talk to me about x to the fourth. How does it compare to x to the second? Steeper, right? Steeper, faster, so it's thinner. So it's going to look something like that. Okay? Talk to me about x to the sixth, everybody. Even steeper is a beautiful way to say it. Okay, so it's going to be something like that. Everybody look right here for 1 second. Okay, look at the left. Left up, left up, left up. So your left arrow, you're going to draw it to a left, point it to a left upper corner of a box. So you just go left up like that. Okay, look at the right. So right is right up, right up, right up. So you're going to either point to the right upper or right lower corner of a box. So you start here, it's right up, and that is called my end behavior. Okay, who says I'm totally with you? Raise your hand, let me see. Okay, awesome. Okay, we're going to fill out this little box really fast, okay? I would never give you the box on a test and say, fill this out. I think that's silly. It's just something to help us, okay? So coefficient of positive, degree even. So it would be like this, guys. Y equals positive x squared, okay? Looks like this, right? So the left, here's your box. Everybody in the room talk to me. Left up or left down? Which one's it going to be? Left up. So grab your pencil, point it to a left upper corner of a box. And then the right side, everybody in the room tell me, right up or right down? Right up. So it's going to look like that. Okay? What if your sign was a negative? Well, then it would take your parabola, and your parabola would be opening down. Okay, so the left arrow, everybody talk to me about the left arrow if the coefficient's a negative. Left up or left down? Left down, so it's going to be like this, okay? And then the right arrow, look on this graph right here, is it going to be right up or right down, everybody?
Right down.
Right down, so it's going to look like that, okay? What if your exponent was odd, like this, y equals x to the third? Just draw a quick sketch of that graph. It would look like that, right? Everybody in the room, left up or left down? Talk to me. Left down. Look at the right arrow. All 30 of you, where's it going to go? Right up or right down? Right up, okay? And what if you have a negative coefficient? Well, then it takes that cubic and it reflects it. So it's going to actually look like that, okay? Everybody in the room, left up or left down? Left up. Right up or right down, you guys? Right down. Okay? Okay, I want everybody to look right here. There's my end behavior. The left arrow is supposed to point to the left, this guy, and he's pointing right. Let me show you what this means, okay? Watch what this means. These arrows right here go on forever. So that means that guy continues on, and this right here means this keeps going on forever. Connect those dots. So if you do this, you're saying that your graph looks like that. Have you ever seen a graph that looks like that? Yes or no? Okay, so do one more thing, okay? Write down left arrow, and then off to the side, I want you to write right arrow. So you have two options for the left arrow, both of which point to the left. Look right here. Here's your box. Left up, left down. So one option is that. The other option is that. Those are the only two options for the arrow that's on the left. Okay? Look at the right. Again, you only have two options. So you're either going to point right there or right there. So your right arrow points right upper corner or right lower corner. That's the end behavior, the end of your graph. Okay? Who says gotcha? I totally get it. Okay, great. Now look right here. A, B, and C are different than D, E, and F. So I want you to go like this and make a brace, and go like this and make a brace. So A, B, and C are all similar. D, E, and F are all similar. So guys, look at A, B, and C. Don't go ahead of me for just a sec. Just kind of look. So A, B, and C, the right-hand side is all multiplied out. The bottom, D, E, and F, they're all factored up. So you can't really immediately see that biggest exponent. Okay, so let's talk about A. So do you see how that term right there has the biggest exponent? Okay, so the x to the second and the 1, they affect the graph, but they don't dominate the graph. The biggest exponent dominates the graph. Okay, so it's a cubic. So everybody draw a cubic like that. But there's a negative in front of the cubic, which tells me that I'm going to have a reflection. So that's actually what, the idea of what the graph's going to look like. All they're asking me for is the end behavior. Every person in this room, left up or left down? Left up, right up or right down? Right down. It's very simple, okay? Did you have to show any work? You really don't. You really don't, okay? The next question. Dominating is the x to the fourth. This negative 7x does affect it, but it doesn't dominate it. X to the fourth is even. That's going to be the shape of a parabola. Okay, I know my parabola opens up because my sign is a positive. Everybody in the room, left up or left down? Left up, right up or right down? Right up. Highlight it in, and you're done. Okay, next one. This guy dominates. These affect it, but don't dominate it. 4 is even. That's a parabola. Everybody talk to me about my parabola. It opens down, right? It's reflected across the x-axis because I've got a negative right there. Okay, everybody in the room, left up or left down? Left down, right up or right down? Right down. There's your end behavior. Okay, all right, so on question A, B, and C, just write this down. Okay, look at largest exponent. Okay, D, E, and F, not so much. So look right here. Everybody look, and this will totally make sense. This is a term, this is a term, and this is a term. What dominates the term from the yellow? The X. What dominates the green? X. What dominates the green? X. Another thing I want you to notice, all those exponents are 1, but also you guys, all the outside exponents are 1s. Okay? So the yellow just gives you an x to the first. The green also just gives you an x to the first. The blue also just gives me an x to the first. So if I did take the time to multiply the whole thing out, which I don't have to, then my biggest exponent would be an x to the, tell me everybody, third. Would I have a negative sitting in front of it, or would it be a positive? It would be a positive. I know it's a positive because the way that I wrote those down, there were no negatives there. Okay, so odd exponent is a cubic, so it looks like that. I don't have a negative, so there are no reflections. So the left arrow is left down, the right arrow is right up. There's my answer, and I'm done. You literally don't have to show any work on that if you don't want to. Okay, who says I'm absolutely with you? Raise your hand, let me see how we're doing. Okay, great. Look at the next one. You guys, see this negative right there? It does affect that first biggest term because the negative has to get distributed through. So I want you to write down the negative. Out of this, what do I get out of that? I get an x to the third. Out of this, what do I get? That would be an x to the second. So that's going to be a negative x to the, you guys, do I multiply those and get a 6, or do I add and get a 5? Add and get a 5. Good. So this is going to be a cubic, which looks like that. But since it has a negative, it has a reflection, and it looks like that. Everybody in the room, left up or left down? Left up, or right down, everybody? Right down. Draw your arrows. There's your answer. Good. Okay, next one. So this right here, what's dominating there? An x. What would dominate here? An x to the, tell me everybody, x to the second. And dominating here is an x to the third. Then when I combine those, what do I get? I get a 6. 3, 4, 5, 6, right? Add those all up. I know that's a parabola, so it's going to look like that. There's no negative coefficient, so I know my parabola opens up. Therefore, my end behavior is left up and right up. That's my answer, and I'm done. Who says, totally good, got it? Let's see. Okay, great. Aside from D, E, and F, I want you to write this down. Add the exponents. So it's not multiplied out like D, E, and F. You have to do it piece by piece by piece. Okay? X and Y intercepts. So we've talked about this. You guys, Weber State's kind of been throwing in some funky stuff on this section that I haven't seen before. So look right here. Can a polynomial function have more than one y-intercept? Tell me that. No, because then it's not a function. So the graph of a polynomial has exactly one y-intercept. Okay. Okay. What about x-intercepts? So if you have y equals x to the fourth and then blah, 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 what's the most x-intercepts you can have? 4. Yes. What's the least x-intercepts you can have? 0. 0. How could you ever have 0 x-intercept if it's an x to the fourth? Go ahead.
If it opens up and it's above the...
Exactly. If it's shifted up and it's above the x-axis. Sure, that could be an x to the 4th. Yeah. Okay, x and y intercept. So we've done this tons of times, you guys, okay? So look what I want you to do. X-intercept and then y-intercept. So the x-intercept is found by letting y be a 0. The y-intercept is found by letting x be a 0. So the y-intercept is going to be the easiest, and you do have to show work, and I know it's annoying, and I'm sorry. Everybody go f of 0 equals 0 to the 3rd minus 0 to the 2nd minus 2 times 0. You guys look up at how I've written that down. Make sure that your notes look like mine, and your homework looks like mine, and your quiz work and test work looks like mine. That's a 0. So you could put an equal 0 at the end. You could always also put an equal, or you could put an equal 0 at the bottom, okay? So I know it's 0, 0. Now, everybody finish this. If 0, 0 is a y-intercept, then talk to me. It's an x-intercept. Does that mean I'm done with the x-intercepts? No. So to find an x-intercept, you're going to let y be a 0. So guys, look, I go into that equation, and I'm going to let y be a 0. So x to the 3rd minus x to the 2nd minus 2x equals 0. Tell me what you would do, everybody. Pull out an x. When you pull out an x, you're left with x to the 2nd minus x minus 2. Don't forget your equals 0. What would you do next? Factor. Yes. So the x to the 2nd is going to go to an x and an x. The 2 is going to go to a 2 and a 1. Signs are different. Biggest is the negative. So the 2 is a negative and the 1 is a positive. I can see right now, guys, that I have 3 x-intercepts. Look. 1, 2, 3. So underneath that, we're going to go x equals 0, negative 1, positive 2. Then I'm going to go to where I'm writing my x-intercepts, and I'm going to go 0, 0, negative 1, 0, 2, 0, and those are my answers. Right here. X-intercepts are right there. Y-intercepts right there. Done. Okay? Okay, let's do this one. If they say, this is super important, guys, listen for a second, because Weber State sometimes just asks like a very general question, find the intercepts. And then people will just list them, but they don't specify which one's which. And if you do that on my test, I'm going to take points off. So what I want you to do is label. So go x-intercept, y-intercept, and maybe make it easy on yourself and add a 0, add those points like that. So we're getting ready. Okay, which one's easier to find, x or y? Y is typically, on this one, not necessarily convinced that the y is easier, but it doesn't matter. We have to do them both. So let's do the y. F of 0 is equal to 0 plus 1 squared times 0 minus 1 squared. 0 plus 1 is a 1. 1 squared is 1. 0 minus 1 is a negative 1. What's a negative 1 squared? It's also a 1. Sure. So that gives you a 1. So your y-intercept is 0, 1. To find the x-intercept, you let y be 0. You have to write this down. Everybody go x plus 1 squared times x minus 1 squared is equal to 0. It's actually really nice because they've done the work for you. So guys, either this is 0 or this is 0. Do you see the exponent right here? Don't let that exponent freak you out. You still just take the x plus 1, set it equal to 0, you get a negative 1. Take the x minus 1, set it equal to 0, get a 1. Come over here, negative 1, 0, 1, 0. You're done. Highlight it. Everything's good. Okay, let's look at C. X-intercept and y-intercept. I'm sure you can predict what we're going to do. We're going to end up graphing these things in just a second. Okay, to find the x-intercept, you let y be 0. To find the y-intercept, you let x be 0. Doesn't matter which one you do first. Let's do y-intercept. So everybody go y equals 0 plus 3 times 0 minus 2 squared times 0 plus 1 to the 3rd. You guys, if you put that in your calculator exactly the way you see it, you would get an answer of 12, and that would be acceptable. Okay? You could also do this. 0 plus 3 is a 3. Negative 0 minus 2 is a negative 2. Negative 2 squared is a 4. 0 plus 1 is a 1. 1 to the third is 1 equals 12. You don't have to. You don't have to do that. You can literally just put it in your calculator if you want to. So the answer is 0, 12. To find the y-intercept or x-intercept, let y be 0. You guys, a lot of people skip this step right here. So please make sure you just write it down and set it equal to 0. You have to show them that how you came up with these numbers. Okay? So set this equal to 0. You get x equals negative 3, positive 2, and negative 1. Go to where you're going to write it. Negative 3, 0, 2, 0, negative 1, 0. You have 3 x-intercepts, and you're done. Yes, sir? In terms of finding them, no, it does not matter. In terms of graphing them, we're going to make a connection right now, what that means. It does affect the graph, but it doesn't affect the value of the x-intercept. Okay, good question. Yes, sir?
So when finding the x-intercepts, we do need to write up that equation again,
Yeah.
setting it equal to 0.
Yeah, it does. I know it's a pain. I know it's a pain. But anyway, okay, look right here. Now you look at the exponents. So look at the exponents on the x-intercepts. If the solution is a solution an even number of times, it bounces. If it's a solution an odd number of times, it crosses. Everybody draw a picture right here. Do an XY axis on both of them. And what I want you to do is I want you to go to a 2 on both of them. And then just add a dot there. I'm just making this up. I just want to make sure you know what bounce looks like. So if we're below the x-axis, right here, guys, approaching that 2, when I hit it, it bounces down and it stays below. Okay, that's a bounce. If it's crossing, then if it's below, as it approaches that, it's going to cross through the x-axis and it looks like that. So just make sure you know the difference between those, okay? Now we're going to go back. Everybody go to part A. Go back to A. And look at those intercepts. And what I want you to do is I want you to put a B or a C for each of them. Okay, so everybody watch. Here's where the exponents matter. See this exponent of, see this x right here? It gave me a 0. The exponent is a 1. So the 0, 0 is a crossing x-intercept. This x plus 1 gave me the negative 1. The x plus 1 has an exponent of 1. Therefore, that is a crossing x-intercept. 2 came from here. Exponent's 1. 1 is odd. Odd means cross. So those are all crossing x-intercepts. Okay, let's go to the next one. Negative 1 came from here. This is an even, so the negative 1, 0 bounces. The 1 came from here, exponent's even, so that is a bouncing x-intercept. Who says I understand? Raise your hand. This is how you were taught, right? Bouncing, crossing. See, raise your hand if that's how your teachers taught you. Okay, good. Okay, let's come over here to C. You've got 3 of them. Negative 3 came from here, exponent's 1, that's a crossing x-intercept. 2 came from here, exponent's even, that's bounce. Negative 1 came from here, that's odd, that means cross. Okay? All right, now we're going to get ready to graph these things in a second. Form a polynomial whose real zeros are given. Leave your answer in factored form. Okay? You guys, a polynomial, it needs to be a polynomial equation. Write the word equation right here. Okay, so on question A, you would say y equals, you could also say f of x equals or something like that. So guys, talk to me. If I have a solution of 2, same thing as an x-intercept of 2, then tell me what I have on my equation. You have an x minus 2, because if I set that equal to 0, I get a 2. The x equals negative 1 gives me a factor of x plus 1. The x equals 0 You could put x and then plus or minus 0, but that's weird. What's that? That's just an x, okay? That answer's wrong. What's wrong with it? It's supposed to be a 4th degree, and what's my degree right now? 3. So I need one more. It doesn't matter where you put it. Let's just make that 1 a 2, and now we've got it. And it says you can leave it in factored form, so we're good, okay? Let's do this one. Y equals, the x equals 2 gives me an x minus 2. The x minus 2 gives me an x plus 2. The x equals 3 gives me an x minus 3. It's wrong. What's wrong? It's supposed to be 5th. So how many am I missing? 2. So I could do like 2, 2, 1, 1, 2, 2. I could just make this guy a 3. It doesn't matter as long as when I end up I get a 5th degree. Okay, however you guys want to do it is great. Questions about that? Okay, this is a big deal right here. I have seen this question right here. I've never seen it until like 2 semesters or 3 semesters ago, and I have seen it on every single, I don't remember if it's a midterm or a final, but I have seen it on every single thing. So the chance of it being there is super high, okay? So if your biggest exponent is an n, then the most number of turning points you would have is n minus 1. Let me give you an example. So if you have y equals 2x to the 4th minus x to the 2nd minus 1, and I ask you the maximum number of turning points, then the answer is going to be 4 minus 1, which is 3. So it's super simple. I've just never stressed it. I've just kind of skated over it and never really talked about it, but it has been coming up often. I'm sure you guys know this, but here's a turning point. Your graph is headed up, and then it turns, and then it turns, and then it turns. So that graph right there has 3 turning points, just so you know, just a direction shift, okay? All right, here we go. Question 4. We're going to graph it now. So part A, find all intercepts. So take your pencil, and I want you to write x-intercept is something comma 0, and then y-intercept is 0 comma something. I have a question for you. Everybody look right here. When we did the bouncing and crossing, look right here for a second, would you please? We only talked about x-intercept. So look right here. Say we had a y-intercept right there. Could my graph do something like this? Bounce off. Can that happen? No. If it bounces off, then it's not a function anymore, right? Fails the vertical line test. So y-intercepts always just cross through to the other side. Okay, here we go with x-intercept. Let y be 0. So everybody go x times x minus 2 times x plus 2 equals 0. So now I have x equals 0, 2, and negative 2. So I'm going to have a 0, 0. I'm going to have a 2, 0. And I'm going to have a negative 2, 0. You guys, the x-intercepts are the ones that you have to decide if they bounce or cross. All of the exponents are 1s. Therefore, they all, talk to me, they all cross. So let's put C's right there, okay? You guys, if 0, 0 is an x-intercept, then 0, 0 is a y-intercept. Could there be any other y-intercepts? No, so you're done with that. Okay, now part B, everybody's going to want to really watch this, okay? So part B, okay, this is how they used to ask these questions. So I changed my workbook so the questioning looked the same as how you're going to see it on Weber States, but now I feel like they're changing the questioning on me again, the way they're going to ask you. So I'm just going to keep doing it like this. And then as we get closer to the final, we might have to change the wording just a little bit. So question B, I want you to just circle it. And I want you to write a note to yourself and say, do this at the end. So I want you to skip it, okay? Question C just asked you to find the end behavior. Now this is super important This is so much better. I never had it in my workbook like this before, and my students just always had to figure it out. Show the end behavior, and they want the power function, okay? So the power function just means that biggest exponent. So guys, look, you have an x and an x and an x. They're all raised to the first. So my power function would be y equals x to the third. And you'd actually have to state that. And then you guys know that a cubic looks like that. So my end behavior would be left down and right up. And both the y equals x to the third and the arrows would be part of the solution. Okay? Okay, let's graph those x-intercepts. So they are 0, 0, 2, 0, and negative 2, 0. They all cross. So what I do, you guys, is I put little C's right there to tell myself, remember to cross. Now here's the other thing, guys, look. My left part of my graph is supposed to be going down. So I know this left part down here is going to be low. Now just watch my pen for a second, okay? So now I know I'm down low. I come up, I cross through. I come down, I hit that guy, I cross through. I come down, I hit that guy, I cross through, and I end up. I was supposed to end up, and I did end up, so I'm feeling pretty good about what I've done. Okay, go ahead and draw it in on yours. And who says, I'm good, I followed that? Raise your hand up high. Okay, now, I am grading your midterm and your final. What used to happen is that Weber State wrote it, then they would come and pick your tests up, and then they would grade it. I actually get to grade these now. I will tell you they have been a little picky sometimes with how high that goes or how low that goes. I wouldn't obsess about it too much, but one thing I would do is this, you guys, look. See this equation? Here's your equation right here, okay? So I want you to take, oh, I have to go back up actually and do part B. I will. But look over here, like how low is negative 3 really supposed to be? Everybody do this, okay? I think you're going to want to do this on your midterm and your final. So make sure you pay really good attention right now, okay? So everybody punch this on your calculator. Negative 3. Then hit that store button we started messing with. It's right here. Negative 3, store, enter. And now I want you to put that equation in your calculator, okay? So everybody go membar. That's right up above the store button. Then hit enter. Then go parenthesis. Membar enter minus 2. Close it, parenthesis. Membar enter plus 2. Close it, enter. And I got negative 15. So you just have to know that it's like really, really low. And I feel like my graph is okay. Okay, now let's do a negative 1. I'm going to show you something new on this calculator, so everybody watch. Let's store in a negative 1. I chose a negative 1 because it's right in between those points. Everybody go negative 1, store, enter. Now I want you to hit the up arrow and then hit it again. So hit up, up. Do you see that you're right on top of that equation again, right? Hit enter, and then it calculates it for you without having to input it. So one thing you might want to do is label that negative 1, 3, and put a dot right there. Let's do a 1. It's so easy. Just go 1, store, enter, up, up, enter, and you got a negative 3. So maybe go positive 1, negative 3, so that they can see you're being really clear. And maybe even you could do some notches. Okay, so the more clear you are, the better it is. Another one you might want to consider is doing a 3. It takes literally 10 seconds at this point. 3, store, enter, up, up, enter. There it is. 15. Mine's probably not great. It's probably coming over too quick. Oh, I just got rid of the whole thing. So it just has to be steep. Oh, and I'm highlighting it. It's okay. Just has to be really steep, something like that. Okay. Okay. That's sufficient. You're done. but we're really not, because here's what Weber State used to say. Weber State doesn't do the bouncing crossing thing. So they don't know how we know whether it's above and whether it's below. So part B, this is literally how they used to word the problem. Find several appropriate points on the graph to determine where the graph is above and where it is below. So look what you have to do. Everybody look at your graph. See these points right here, guys? Look, this is kind of hard to understand, so look. Here's a point, here's a point, here's a point. It takes your number line and divides it into 3 regions. So you've got a region here, you've got a region here, you've got a region here, and you have a region here. Okay, so when you do part B, this is what you have to do. So write yours in part B, but I'm going to keep my graph right here. Okay, so I'm going to go X, and then I'm going to do Y, and you have to test 4 regions. 1 point for each of those colored regions that we divided it into. So on the left, I would choose a -3. In the yellow, I would choose a -1. In the pink, I would choose a +1. And on the right, in the lighter blue, I would choose a 3. Now, you guys are lucky because my students used to have to show a ton of work on how they got Y, and now I know we don't have to. So let's put in a -3. It'll take 10 seconds. Everybody go -3, store, enter, up, up, enter, and I got -15. And negative means below the x-axis. Guys, look, left 3, that means you're below the x-axis. Everybody go -1, store, enter, up, up, enter, and you got a 3. Same thing for 1. We already did 1 a minute ago. It was a -3. Do a 3. 3, store, enter, up, up, enter. You get a 15, and that is your correct answer for part B. That's all you have to do, okay? So here's what happens in this class, you guys, and I'm not trying to be negative. Was B necessary in terms of knowing how to graph that graph? Tell me. No. Weber State thinks it's necessary. We didn't think it was necessary. We already had it. Sometimes you have to jump through hoops. What do I mean when I say jump through hoops? Do you know that phrase? You have to do something that we don't think is really necessary, but we still have to do it because we know that they're the ones who are going to be deciding how to grade this thing, okay? Okay, here we go with question number 6, same thing, okay? Find all the intercepts, okay? So everybody go x-intercepts, y-intercepts. To find the x-intercept, let y be 0. To find the y-intercept, let x be a 0. So let's let y be a 0. So everybody go x plus 1 squared times x minus 1 squared is equal to 0. So that gives me x equals -1 and x gives me +1. So my x-intercepts are -1, 0 and 1, 0. You guys, does the -1 bounce or cross? Tell me that. It bounces because your exponent's in even. Talk to me about the 1, 0. It also bounces. Good. Okay, so those are your x-intercepts. To find the y-intercept, let x be 0. So everybody go f of 0 is equal to 0 plus 1 squared times 0 minus 1 squared, and I know that that's a 1. So I'm going to go 0, 1, highlight it, and I'm good. Part B, I know that's jumping through hoops. I'm blowing that off until the end. Okay? Describe the end behavior and tell me the power function. You guys look at the equation. I know it's going to be y equals, or maybe I better write f of x equals, and it's going to be x to the, talk to me. 4th is correct, is the power function. I know that's going to be a parabola. It's not a negative, so I know my parabola opens up. So my arrows are left up, right up. There's my end behavior. End behavior and power function. Okay, now let's graph it. So I have a -1, 0. That's going to bounce. I have a 1, 0. That's going to bounce. And I have a 0, 1. Okay, so it looks something like this. And another, you guys, like I said, another recommendation is I would put B's like that. Okay, You don't have to, but we're going to start graphing rational functions in a few days, and it gets pretty complicated. Okay, so I know the left is supposed to be up. See my end behavior? It's left up. So I know this is going to be up. Okay, so watch me and then you do it. Okay, so I'm up high, come down, hit it, bounce, hit that, come down, hit it, bounce, come up, draw my arrows, done. There's my graph. Okay, you guys go ahead. Okay, part B. I'm going to do part B right here. You do part B in the part B section. Okay, somebody answered this question. If I have two x-intercepts, like I have on this graph, how many regions do I have to test? Can you tell me? There are 3. Look right here. Here's one. There's one right there in blue. There's one right here in green. And there's one right there in yellow. Okay. Somebody shout out a number in the far left region. Can I use a -1?
No.
No. What could I do? -2. How about a green? 0. Sure. How about the yellow? 2 is great. I know that 0 is going to be 1. I could fill that in because that was the y-intercept, right? Everybody go -2, store, enter. Now I can't do the up, enter because I haven't even put this guy in my calculator yet, ever. So I'm going to have to put that in. So everybody go parenthesis, membar, enter, +1, close your parenthesis, hit the x squared button. Then go parenthesis, membar, enter, -1, close it, x squared, enter, and you get a 9. So I know if it's a -2, then I get a +9. Let's do a +2. Everybody go 2, store, enter, up, enter, and I get a 9, and part B is done. This just means right here, above because it's a positive, above because it's a positive, above because it's a positive. So it's always above the x-axis. You don't really have to do that above, but I was just showing you. Okay? All right. One more. And the rest of that part is just kind of a summary. Okay? Find all the intercepts. So x-intercept, y-intercept. To find the x-intercept, let y be 0. To find the y-intercept, let x be a 0. Let's let x be a 0. So everybody go f of 0 is equal to 0 plus 1 squared times 0 minus 2 to the third times 0 plus 3. I remember this being very large. Let's change it. Let's change it. So let's make this, unless I adjusted my graph. Did I adjust that graph? No. Okay, let's make this a 1 right there. So then that's a 1. Okay, and then my number is going to be way more reasonable. When I put that in my calculator, I get a -3. Okay, so when x is a 0, then y is a -3. Now let's find the x-intercept, so let y be 0. So everybody go x plus 1 to the second times x minus 1 to the third times x plus 3 equals 0. So that gives me x equals -1, +1, and -3. So the -1 came from here, so I'm going to go -1, 0. That's even, so it's going to bounce. The 1 came from here, exponent's odd, so I've got 1, 0 crosses. -3 came from here, exponent's a 1, so it crosses. Okay, so there we go. Part B, skip it. Show the end behavior. Okay, everybody write f of x equals x to the, everybody tell me, 6. That's correct. Yep. 2 here, 3, 4, 5, 1 more gives me 6. I know that's a parabola that opens up, so my end behavior is left up, right up. There we go. Okay, now go to that x-axis. Everybody plot the point -1, 0 and put a B, and then do 1, 0 and put a C, and then do -3, 0 and put a C. You graph it. Go ahead. Okay, everybody look right here. My left is supposed to be up, so it's going to be up high, come down, cross through, hit that, bounce down, come down, go like that, cross through, come up. Okay, go to part B. 3 x-intercepts. You tell me how many regions I test. 4. Everybody in the room, people mess up on this. This is a sore spot on this question. Tell me the far left region. Everybody in the room, shout out a number. -4. Next one. -2. You know what people do? Watch this. 3, 4. What's wrong with 3, 4? I tested the same region twice, and I didn't test the third region at all. So instead of 3, put a what, everybody? 0. Okay, grab your calculator. Everybody go -4, store, enter. Then let's put that in our calculator. So everybody go parenthesis, membar, enter, +1, close it, x squared. Parenthesis, membar, enter, -1, close it. How do I do a third? You hit that caret button like that, the arrow up button. So raise it to the third, hit that button, and then a 3, then parenthesis, membar, enter, +3, close it, enter, and I got 1,125. Is that what you got?
Yeah.
That's big. Okay, let's do the next one. -2, store, enter, up, up, enter, -27. 0, 0, store, enter, up, up, enter, -3. 4, store, enter, up, up, enter, 4,725. Okay, so -4, I'm going to erase my -4. Actually, I'm just going to override it. Is that okay? If I, oh no, I can see it. I think I can do it. Yeah, we're good. Okay, so I'm just going to make it like crazy, crazy, crazy steep, like that. Okay, and then the -2 is supposed to be -27. You know, I don't even know if I'd alter it. You could just put a point right there and label it -2, -27. I think that would be sufficient. The next one is 0, -3, but look how I have them dipping down the same. So use your eraser. My machine, actually, you know what? I can erase differently. I think I can do it. Okay, I'm good. Okay, so this is supposed to be a -3, right? And the other guy's a -27, so it should be maybe, you know, something like that. So it's, you know, represented properly. Put a dot right there, call it 0, -3. And then the 2 is supposed to be 4,000, which is crazy. So it would be something just super, 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 super steep, like that. Okay, I don't know how picky they're going to get on the accuracy of those numbers, but you get the idea. Okay, this part right here, exactly what we just talked about. Continuous means it just flows. End behavior, intercepts, crossing and bouncing. Turning points, that's really big. I should have probably added that in here. On this guy right here, everybody just answered this because I really think you're going to see it. What's the most number of turning points that would be possible on that graph? Ooh, it's 5. Yeah, you take the biggest exponent, which is a 6, subtract 1, so it's a piece of cake, right? But just make sure you know it because I think it's going to be